Aziz dostum benden küsüp incidi. Ayrılık. Okay, guys. So today we're gonna do the solutions for the workbook problems. We may not doing the all of the solutions by meaning that we will do all the questions, but not all the parts of the questions. Okay, that's an important part. Maybe we will. Let's see. Okay, so we start with the question numero uno. Question numero uno says that copy this table. We already did it to our whiteboard, and then tick the correct boxes. So the table says look at the number and check if the number is rational or irrational. So square root of 36 is equal to 6. 6 is an integer, so it's a rational number. Square root of 48 is not nothing, is nothing, right? So square root of 48. So we say that there is not any number. So no number exists, right? No number exists such that its square is 48. Then square root of 48 should be irrational. Square root of 64. Square root of 64 is equal to 8, so it is rational. Square root of 84, no number exists. You cannot find any number which its square is equal to 84, so square root of 84 is irrational. Cube root of 100. So if that would be square root of 100, we know that that's equal to 10, so it's rational, right? This is rational. But cube root of 100 doesn't exist. Well, it does exist. There is such number, but it's not rational, right? Because you cannot find so irrational because you cannot find any number that its cube. So there is no let's say no rational number such that it's cube, not square, because we now it's a cube root, right? Its cube is 100. So that means it is cube root of 100 is irrational. Next one. Look at these numbers. That's it. We looked at them. Third question. Write whether each of these questions is an integer or a surd. What is a surd? Surd. There are uh how do you call it, features of the surd, okay? Two conditions that a surd has to satisfy in order to be a surd, in order for the condition that we can call it a surd. The first condition, surd is a number, okay? Surd is some type of a number. The first condition for that number is it has to be irrational. So if you are not irrational, you cannot be a surd, okay? The second condition is that it has to be, let's write it a little nicer, has to be in the root, okay? In the root. Doesn't matter which root. It can be square root, cube root, fifth root, whatever root, but it has to be in the root, okay? Let's check the numbers. So we gotta check if the numbers are integer or a surd, okay? Square root of 25 is equal to 5. 5 is an integer, so this guy is an integer. Cube root of 5. Cube root of 5, what the hell is that? I ain't know. There is no number that its cube will be 25. So that means that cube root of 25 is irrational, okay? It is irrational. First of all, it is irrational. Cube root of 25 is irrational. So this condition is satisfied. Is it in the root? Yes, it is. We say it. Cube root. So it is in the root. So that is a surd, okay? Surd. Every surd is irrational, right? Because first condition to be a surd is being irrational. So every surd has to be irrational. Anyways, square root of 125. What the hell is that? I don't know, right? There is no number that its square is 125. So that means square root of 125 is irrational. Is it in the root? Exactly. I just said it is square root of 125. So it is in the root and it is irrational, then it is a surd. Next question. Sorry, we forgot the second question. Look at these numbers, okay? We are looking at them, and then we have to find which numbers are irrational and which numbers are integer. Okay. So this guy, 12.77, is it An integer? No, because integers are whole numbers. This is not whole. This is point something. So it's not an integer. Is it irrational? No. If that would be an irrational, I wouldn't be able to write it as a ratio, but I can write it as a ratio. How? So it is 12.77. I'm not gonna use the point here. So I'm gonna write 12.77. And after the point, after this point, I got two numbers, right? So I'm gonna write two zeros and one, always one into the left. Okay. So you can calculate this, and this will be exactly equal to 12.77. At your level, I can only tell you that whatever you see without the square root, and that's a number that the decimals doesn't go infinity or anything. There are finite number of decimals, and the number is not in the root. It cannot be irrational. It's not true, but for your level, it is. Okay. In general, in mathematics, there is no such rule, but for your level, there is. Okay. So, anyways, this guy is not irrational, is neither irrational nor integer. This guy, negative 36, it's an integer. This guy, square root of 27, irrational, because there is no number that you can get it square and it would be equal to 27. And you can do the other parts. Okay, let's do the last part as well. Negative cube root of 8. So cube root of 8 itself is equal to 2. Negative cube root of 8. So negative 8 cube root. So from this part, cube root of 8 part, I'm getting 2, right? And then I'm going to add this negative because it was outside of the root. So it will be equal to negative 2, okay? So it is an integer. Integer. Okay, question numero 4. Question 4 says, in each of these numbers, is each of these numbers rational or irrational? Give a reason for your answer. So, square root of 3 plus 6, it is irrational. Irrational. What is the reason? You can find out yourselves, but you can think of that. Well, that is an integer plus irrational thing, so it has to give you an irrational thing at the end of the day. So square root of 6 plus 3, so square root of 3 plus 6 is equal to square root of what's 3 plus 6? 9. Square root of 9 is 3, so it is rational. So this guy is rational. This guy, square root of 64 plus cube root of 64. Square root of 64 is 8. Cube root of 64 is 4. So 8 plus 4 is 12. So it has to be rational. Cube root of 8 plus cube root of 19. Cube root of 8 is 2 plus cube root of 19. I don't know what the cube root of 19 is. So that is irrational. Okay. Next one. This is a solution video. So there is no vast explanations here, okay? This is for the solutions only. Question number 5. Find 1.5 squared, okay? 1.5 squared, so it's equal to 1.5 times 1.5. So you can make this calculation and you can find, so how to make this calculation? This like this. So 5, 7, 5, 1, 5, 2, 2. So 225. So 225 will be the answer. 225. Okay. That's it. We found 1.5 squared. That's equal to 2.25. Show that square root of 2.25 is a rational number. So square root of 225 is a number that its square is 225. So square root of 225, we already found out in the part A that 1.5 square is 225. So instead of 225, I can write 1.5 square. And this square and square root cancels out, and that's equal to 1.5. 1.5 is a rational number, so we showed that square root of 225 is a rational number. How did we cancel out these 2 and square root? Just like this. For example, if you have square root of 4, essentially it means square root of 2 squared. So squared and square root cancels out. That's why square root of 4 is equal to 2. Okay, this is the exactly same idea. Instead of 4, we wrote 225. Instead of 1.5, we wrote 2. Okay, this is the exact thing. Just check it out or stop the video. If you have any problem, stop the video and look at the screen better. Okay, next one. Is 20.25 a rational number? Okay, let's check it out. If there is any rational number that its square is 225, 20.25. I think there is, the number should be 4.1. You already know that the square of 45 is 2025. So square of 4.5 should be 20.25. That means that square root of 20.25 has to give you 4.5. So this is a rational number. So yes, and we gave a reason here. This was where we gave a reason. Next one is cube root. Okay, you got the idea. You have to make sure that if there is a number where its cube is equal to 1.331, you can use your calculator and you can try to check what is a cube root of uh, 1313. Okay. Well, if it is little hard, I can give you a hint. What you can do is that you already know that 10 cube is equal to 1,000, right? So we need some number that its cube, which should be like 1,331. I can guess that that number should be 11 if there is any such number. So 11 squared is 125. Multiply it with 11 again. So 125, 125. It gives you 1,331. And since we got 1.5 times 1 point, so that means that 1.1 cube should be what? 1.1 times 1.1 times 1.1. So 1.1, 1.1 is 1.21 times 1.1. That should be equal to 1.331. But we have two numbers after the decimal, one number after the decimal. In general, we will have three numbers after the decimal. So number will be 1.331. So we found the number that, so this number is equal to 1.1. So this is indeed a rational number because 1.1 is a rational number. How can I show it as a ratio? 11.10 over 10, sorry. Okay, anyways, 6. Without using a calculator, show that this works. We'll show only part A, okay? Then you can use the idea and get the other parts. So part A, 3 has to be smaller than 41 cube root, and that has to be smaller than 4. So once you see this kind of things, inequalities, by things we mean inequalities. So this is 6A. Already know that we have to get rid of, so get rid of roots, okay? Which root do we have here? We have cube root. We have to get rid of it. How do we get rid of cube root? We have to get the cube of each side. So it will be 3 cubed, smaller than, so these signs won't change. Cube root has to be smaller than 41 cube root 3. 3 cube has to be smaller than this, and that has to be smaller than 4 cubed. So now check if it is true. So 3 cubed is 27. This is smaller than something, and that is smaller than 4 cubed, which is 64. So now let's check it out. So 3 cancels out. We got 41. So this is indeed true, right? 41 is bigger than 27 and smaller than 64. So this is true. Then this has to be true, okay? So we showed that this works. In general, what you can write, if you have anything like A, B, C, if this is true, if true, then A to the power of n, B to the power of n should be the same with C to the power of n for n smaller than or equal, higher than or equal to 1. Okay, that's it. Actually, no, higher than or equal to 0. So you can't use like 3 to the power of -2 has to be smaller than 4 to the power of -2 just because 3 is smaller than 4, okay? But since these powers are higher than 1 or higher than 0, it works. Then, question number 7. Without using a calculator, find an irrational number between these guys. So it's the same idea with question number 6. So here, question number 7, we gotta have some number in between 6 and 7. For example, we are doing part B randomly, 6, 7, and this is some number, I don't know. It has to be an irrational number, so I know that it has to be in some root, okay? So then with the same idea, let's use a square root, for example. With the same idea, let's square both parts. So 36, 49. So it means that if my number is anything in between 36 and 49 in the root, let's say 36, 49 works with, I'm sorry. So let's find the number in between 36 and 49, okay? Let's say 40. So if this is true, then this should be true as well, right? So what do we got here? Then square root of 36 should be smaller than square root of 40. That should be smaller than square root of 49. So square root of 36, I'm just writing the exact same things again, should be smaller than square root of 40. I'm just putting everything into the square root. That should be smaller than square root of 49, right? So what is square root of 36? That's 6. Should be smaller than square root of 40. Should be smaller than square root of 49, which is 7. So we found the number square root of 40, which is in between 6 and 7. Next one. Without using a calculator, estimate this stuff to the nearest integer. So we will do part B, for example. We will do 8b. So 8b. We gotta write to the nearest integer. So 350 cube root. So we got cube root of 350 to nearest integer. How do we do that? We will guess. We will guess that which number's cube is equal to something close to 350. So 1 cube is 1, 2 cube is 8, blah, 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 blah. 5 cube is 125. 6 cube is 216. 7 cube is, I think, 729 or what? No, 343, sorry, 343. So 7 cubed is very close to this number. So that means uh, if 7 cubed is equal to 343, then 343 cube root is equal to 7, right? Then 350 cube root has to be something closer to 7. So the closest integer to this guy is 350, okay? You can get the 8 cube and you will see that it will be far away from this number, okay? But 7 cubed is very close. So the answer is 7. The closest integer to the cube root of 343 is 7, okay? Question number 9. Arun says some weird thing. Is Arun correct? Do you think this is a rational number? Arun says, my calculator shows this and this does not have a repeating pattern, so this is irrational, okay? No, it's not correct. Why? He's not correct, sorry. Why he's not correct? Because just because your calculator shows something like that, and the number does not stop in your calculator, because in calculators, there is a finite number of numbers that they can display, right? So it means we do not know if the numbers, like the decimals, are finite or not. I don't know. Because I don't know, I cannot have any idea if the number is rational or irrational by just looking at your calculator if all the decimals are there, okay? Maybe those decimals are finite, maybe those decimals are repeating. I don't know because my calculator only showed me in this Arun's calculator only showed him 9 digits. Maybe there are just 10 digits. Maybe there are just 9 digits. I don't know. That's why I can't say anything. Part B, do you think this number is rational or not? Well, we can solve this. So look at the number 2, 7, 81. Let's try to see it as a ratio. So we got to write 81. And over here, we got to write 2 times 81 plus 7. I think you should already know how to make it as a 1 ratio. So I'm not teaching that. So 81 here, 2 times 81 is 262. So 269. Sorry, 169. 169. That's it. And that is equal to square root of 13 squared over 9 squared. And that is equal to square root of 13 over 9 squared. Then square root cancels each other. So it's equal to 13 over 9. So it turns out this number from the beginning is equal to 13 over 9, which is rational. So it is rational, yes. We gave a reasoning. We calculated everything. 10. Use a calculator to show that this is, well, you can use a calculator, but I can use a better method because this number is square root of 2 and square root of 32, right? Find two rational numbers. Okay, you can do the part B. So 10a. We got to do the calculate without the calculator thing. This is times equal to 32. Okay, so that is equal to what? Square root of 2 times 32 is 16 times 2, right? Very good. And in square root, we can just separate the roots if it is a multiplication. So 2 times 16 times 2, right? Then that is equal to, so what was 16? Square root of 16, it's just 2, just 4 times square root of 2 times square root of 2. 4 times. We multiplied two square root of 2's. What do we do in mathematics when we multiply two things, two same things? So we get the square of it, right? If you multiply 5 times 5 times 5, that's the same thing as 5 to the power of 2. If you multiply square root of 2 times square root of 2, it is square root of 2 to the power of 2. So power and root cancels each other, and it's just 4 times 2, that's equal to 8, which is rational. Okay, good. Question 11. Let's see part C, for example. I'm just reading part A first. Find two irrational numbers with the sum of 5. Well, very easy. Let's just choose one irrational number and then we can find the other one. So first one, let's choose first one as square root of 2, okay? Then the second one should be something so that their sums should be equal to 5, right? Square root of 2, sorry, square root of 2, 2 plus some number, then the sum is equal to 5. So then x is equal to 5 minus square root of 2. So my first number will be square root of 2. My second number will be 5 minus square root of 2. So we found two irrational numbers that when we sum them up, we get 5. So sum these two numbers up 5 minus square root of 2 plus square root of 2. That will be equal to 5. Okay. Is it possible to find two rational numbers with a product of square root of 5? Give a reason for your answer. No, it isn't. No. Why? Because we know that rational numbers can be shown as a ratio, right? Rational numbers can be shown as a ratio. So what does it mean? It means that, let's say, first rational number, we can show it as a ratio. So I'm guessing that we show it as A over B. So the second rational numbers, we can still show it as a ratio, X over Y, right? When we multiply them up, because it says that with a product of square root of 5, right? When we multiply them up, we will get AX EY. So it is still a ratio, right? Still ratio. So then this is still rational. So when we multiplied two rational numbers, we get rational results. So we cannot get irrational result. Okay, that's why no. Question number 12. This Venn diagram shows all the numbers on a number line. Very good. A is set of integers. B is set of rational numbers. Okay, very good. So why you see that everything in A is also in B, right? So B has some extra elements over here, but everything A includes, B also includes, right? So it means that uh every integer is also rational. We already knew it, right? Every integer is also rational because rationals are what? Rationals are 1, 2, 3, 4, -1, blah, 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 blah. Also 3 over 4, but 3 over 4 is rational. So rational, not integer. Okay. -4 is rational and integer. So for example, now if you gotta fix them up, what I can write over here, I can write that, I can guess that 4 is rational and integer, right? So 4, -4, -3, 1. So those are here, or 0, right? And numbers like 3 over 4, 1.5, negative 2.3, those are over here because they are, you see, they are rational, but they are not integer. Okay. Copy the diagram and put each of the numbers in the correct place. So now, let's copy the diagram somewhere here. So here we got A, and the big thing is B, okay? So now let's check. We got 25, 5.5. Okay, let's do some. So 25 is integer, so it will be here. So let's choose the integers first, right? So 25 is an integer. Square root of 25 is equal to 5, so it's also an integer because it's 5. Cube root of 25, it's not an integer, right? But it's also not rational, so it's nowhere, right? It's nowhere. It's like somewhere here. It's neither integer nor rational, right? So it's not going to be anywhere. This guy, it is rational, not integer. It is rational, not integer. So 5.5 and 5, 19, 5, something like that. Okay, good. Question number 13. If n is equal to 20, find the value of this, value of that, and value of this. Okay, so let's say 13a1. Okay, so n is 20. We gotta find square root of n plus 2. So n was 20, so square root of n, instead of n, I'm gonna write 20 plus 2. So this is part 1. Part 2, square root of n minus 2. Instead of square root of n, I'm gonna write square root of, what was n? N was 20, right? Square root of 20 minus 2. So this is part 2. Tuck, tuck. And part 3, we gotta find square root of n plus 2. No. So we gotta find this square root of n plus 2 times square root of n minus 2. So that is equal to square root of 20 plus 2, square root of 20 minus 2. So that is equal to square root of 20. So we are just gonna expand the brackets. Square root of 20 times square root of 20 minus 2 times square root of 20. So I'm just multiplying this plus 2 times, now multiplying this and that, 2 times square root of 20 minus 2 times 2, right? This and that. So let's see. Square root of 20 times square root of 20 is just square root of 20 squared minus 2 times square 20 plus 2 times square 20, cancel each other, minus 2 times 2 is 4. So square root of 20 squared, square and root cancel each other. So it's just 20 minus 4 is equal to 16. So we solved this part as well. Part B. If n is an integer, then this is also integer. Let's see if Sophia is correct. So let's see part B. So n is integer. So now we got to check if this is integer or not. N plus 2 times n minus 2. So that will be equal to n, and I'm just expanding the brackets, minus 2n plus 2n minus 2. So again, minus 2n plus 2n cancels each other. Square root of n times square root of n, square root of n squared, minus 2 times 2, 4. What is square root of n squared? Square root and square cancel each other, so it's just n minus 4. Remember, n was an integer, right? That's what the Sophia says. So if n is an integer, n minus 4 is this whole thing, right? Is also an integer, right? Because integer minus 4 is another integer. So Sophia is correct. Yes. That's it. See ya. Yeah, I'm gonna stop the recording now.